Welcome to Headline Hub Updates. Subscribe and press the bell icon for more updates. Breaking news: humanity's greatest question has finally been answered. We are not alone. Today, August 14, 2025, scientists at the Space Telescope Science Institute in Baltimore are grappling with the most profound discovery in human history. The world is holding its breath as the news spreads across every continent, every city, every home. The data arrived quietly, a stream of numbers from 500 light-years away, almost unnoticeable at first, hidden in the endless flow of cosmic information. But those numbers, when decoded, reveal something extraordinary: a living, breathing world orbiting a distant star. For millennia, we've gazed up at the night sky and wondered, is anybody out there? Are we truly alone in this vast universe? Today the universe has answered, and its response is more wondrous than we ever imagined. It wasn't a radio signal or a spaceship, but the unmistakable chemical fingerprint of life, complex molecules in the atmosphere, impossible to explain by any known process except biology. The realization came slowly, as an anomaly in the data, a spike where none was expected, a subtle but persistent clue that demanded attention. Teams of scientists tested every alternative, scrutinizing the evidence with fierce skepticism. They challenged every assumption, rechecked every calculation, determined to rule out error. Yet every test pointed to the same conclusion: the signal was clear, the evidence robust, and the implications staggering. We have found a world teeming with life, an entire ecosystem thriving under an alien sun, with its own unique forms and cycles. Imagine a darkened control room, monitors glowing in the dim light, scientists staring at a tiny bump in a line of data that's traveled for 5 centuries across the void. They all know what it means. This isn't just another rock in space. This is a moment that will be remembered for generations. This is a second Genesis, a place where chemistry has given rise to biology, independent of Earth, proving that life is not a cosmic fluke, but a natural outcome of the universe. The silence in that room is the sound of a paradigm shifting, as the weight of discovery settles in. This moment is a testament to human curiosity and centuries of scientific progress. Every discovery, every failure, every question has led us here. We built these tools not knowing what we'd find, driven by the impulse to explore, to push the boundaries of the unknown. We pointed our greatest eye at a distant star, and in the faint light of one of its planets, we saw a reflection of ourselves. Not our technology, but our biology, our very essence. The universe is not a sterile, empty place. It is alive with possibilities, richer and more mysterious than we ever dared to dream. It is a cosmic garden, and we have just found our first neighbor. A companion in the vastness, proof that life can flourish beyond our world. Our understanding of our place in the cosmos has been forever transformed. We are no longer just observers, we are participants in a living universe. The search is over. The answer is yes, we are not alone. And now a new chapter in the story of humanity begins. To truly grasp the magnitude of this discovery, you first need to understand the remarkable instrument that made it possible: the James Webb Space Telescope, or JWST. This is not just another telescope, it's a technological marvel, representing decades of international collaboration and innovation. Launched in 2021 after years of anticipation, JWST now sits 1 million miles from Earth, far beyond the reach of our planet's shadow. Its massive sun shield protects it from the sun's heat, allowing it to peer deep into the cold, ancient universe, capturing light in the infrared spectrum that's invisible to our eyes. It's the most powerful observatory ever built, designed to look further back in time than any telescope before it, revealing the first stars and galaxies that formed after the Big Bang. With its unprecedented sensitivity, JWST is opening a new window onto the origins of the cosmos. But JWST isn't just for studying the distant past, it's also perfectly suited for exploring exoplanets, worlds orbiting other stars. By analyzing the faint heat signatures and the chemical makeup of their atmospheres, searching for signs of habitability or even life. Before JWST, astronomers could detect exoplanets and measure their sizes and orbits, but they couldn't truly study the air that surrounds them. The details of their atmospheres remained a mystery, hidden in the glare of their parent stars. Now, thanks to JWST's giant golden mirror and its advanced spectrographs, scientists can isolate a planet's faint atmospheric whisper from the overwhelming stellar shout, separating the subtle signals from the noise. The telescope dissects starlight that has passed through a planet's atmosphere, reading the unique chemical barcodes left behind. This allows us to identify molecules like water vapor, methane, and even potential biosignatures. Every image and spectrum it sends back is a revelation, rewriting textbooks, challenging our assumptions, and sparking new questions about our place in the universe. In the summer of 2025, JWS delivered a result so profound that it will echo through science and culture for generations to come, inspiring new research and igniting imaginations worldwide. Today, it stands as our primary tool in the search for life beyond Earth, pushing the boundaries of what we know and what we dare to dream. The planet at the center of this drama is Kepler 186f. Discovered in 2014, it was the first Earth-sized planet found in its star's habitable zone, the Goldilocks region. For over a decade, it was a tantalizing candidate, orbiting a red dwarf star 500 light-years away. Its year is just 130 days. For years, it was a dot of data, a world of possibilities. Everything changed when JWS turned its golden eye toward it. Using transit spectroscopy, JWST captured the starlight filtering through Kepler 186f's atmosphere. Scientists hoped to find hints of water vapor or carbon dioxide. Instead, the data shouted, a complex, layered, profoundly biological signature. The chemical composition couldn't be explained by geology or simple chemistry. The signal was checked, rechecked, and repeated, always the same. The air on Kepler 186f is being actively shaped by a global biosphere. Why are scientists so certain? Because the evidence is overwhelming. JWST found a suite of gases in Kepler 186f's atmosphere that, together, have no known explanation except biology. Most crucial, large amounts of both oxygen and methane, chemical enemies that shouldn't coexist unless constantly replenished. On Earth, that's the work of life. The sheer quantity of oxygen detected is staggering, 15 to 20% similar to Earth's. The clincher dimethyl sulfide, or DMS, a gas produced almost exclusively by life on Earth. The chemical evidence is robust, clear, and undeniable. Let's dive into the chemical cocktail JWS uncovered. The primary component is nitrogen, but the active ingredients tell the story. Abundant water vapor confirms the planet has liquid water. Oxygen's strong spectral lines suggest photosynthesis or a similar process has been active for ages. Methane points to metabolic processes like those of methanogens. The stable coexistence of oxygen and methane suggests a complex, diverse ecosystem. And then, dimethyl sulfide, a powerful biosignature, unlikely to form without life. Kepler 186f likely has vast oceans teeming with microbial plankton. The air of this alien world might even carry a faint, familiar scent of the sea. Why is this atmospheric mix so compelling? A dead world's atmosphere is stable, in chemical equilibrium like Mars or Venus. Life, however, creates disequilibrium, a constant chemical imbalance only maintained by biology. The coexistence of oxygen and methane is a planetary-scale signature of life. On Earth, oxygen only appeared after photosynthetic life evolved. The oxygen on Kepler 186f tells a similar story. A biosphere has transformed its world. DMS is the smoking gun, a complex molecule that non-living chemistry rarely produces. Life builds complexity. Nature without life favors simplicity. The presence of DMS suggests a sophisticated metabolism and an intricate ecological web. Kepler 186f is alive not just with chemistry but with biology. How did we listen to a planet's atmosphere from 500 light-years away? Transit spectroscopy. As Kepler 186f passes in front of its star, a sliver of starlight filters through its atmosphere. Each gas absorbs specific wavelengths, leaving a unique barcode in the light. JWST's instruments spread this light into a spectrum, revealing which colors are missing. By comparing the star's light with and without the planet in front, scientists isolate the atmospheric signal. For Kepler 186f, the barcode was clear: water, oxygen, methane, and DMS. It was a message in a bottle, written in the universal language of light and chemistry. What might Kepler 186f look like? It's almost certainly a rocky world with vast oceans. Its red dwarf star would cast a dim reddish-orange glow like a perpetual sunset. Plant life would have evolved to use red and infrared light, so foliage might be purple, red, or black. Imagine standing on a shoreline under a dim orange sky, with black-leafed forests on the hills. The planet is likely tidally locked, with one side in permanent day, the other in night. The most habitable region would be the twilight ring between day and night. Life would be hardy, perhaps thriving in deep oceans or constant twilight. No signs of technology, just biology. Kepler 186f is a garden world, not a city planet. The discovery of life on Kepler 186 FF is a moment of profound reflection, a turning point in our understanding of the cosmos and our place within it. Our solitude is over. We are part of a larger cosmic biology, connected to a vast network of life that stretches far beyond our home planet. This knowledge changes everything: science, philosophy, our sense of self. It challenges us to rethink what it means to be alive and conscious in a universe teeming with possibilities. The universe is not just stars and galaxies, but neighbors, potential friends, mysteries, and perhaps even future collaborators in the grand story of existence. This is a triumph of human curiosity and the scientific method, a testament to our relentless drive to seek answers to the biggest questions. We found this life because we asked the right questions and built the right tools, pushing the boundaries of technology and imagination. The silence of Kepler 186 F, no technology, suggests life may be common, but intelligence rare. The planet's quiet beauty reminds us how precious and fragile intelligent life might be. Perhaps the leap to civilization is the true rarity, a delicate step that only a few worlds may ever take. We are the custodians of the only known technological intelligence in our corner of the galaxy, holding a unique responsibility to protect and cherish this gift. This discovery should fill us with responsibility, not arrogance. It calls for unity, humility, and a renewed sense of stewardship for our planet and beyond. Kepler 186 F is the first. How many more living worlds await? Each new discovery will reshape our understanding of life's diversity. We are explorers of worlds, standing at the dawn of a new age, ready to reach out and learn from the universe itself. The universe is whispering its secrets. We just have to keep listening and never stop searching for our place among the stars.